Okay, so I was showing quite a few examples of taking one number off of the denominator. I want to make sure that you do not take both numbers off at the same time. So notice here I have numbers on the bottom and on the top. So what I don't want you to do not say, oh, here we go, I'll write this down, and then I'll write this down, and then I'll take both of those numbers off at the same time, and then I'll figure out the inequality. Wrong. You can't do that because there's too much going on. So we want you to go slow, work slow to make sure that you keep the inequality. So let's write down, and let's take one number off. Let's take this off. So keep the numerator the same and then make this. So which is smaller? Which has more on the denominator? This one. So it's smaller. Okay, so now can I take this 3 off is the question and keep the inequalities going in the same direction? I need the inequalities in the same direction. Is it true? So go slow and think about it. Is it true that n plus 3 is larger than n? Yes, it is. So I can do this inequality. Okay, so this gives us 1 over n. So I've got this one is larger than 1 over n. What do I know about the sum of 1 over n? This diverges by p-test. It's the smaller of the two, so therefore I get that this diverges also by basic comparison test. Okay, so let's look at the next one. So sine of n plus 3, n to the 4th, whoops, plus 4. Okay, so let's take off one thing. I'm going to start with the denominator. So sine of n plus 3 and n to the 4th. Okay, so which has more in the denominator? This has more in the denominator, so that's smaller. Okay, so if I want to get to a p-test, I want to get rid of the sign. So what do I know about sine? I know that sine of n is always smaller than or equal to 1, correct? So in order to keep the inequalities the same, couldn't I replace sine of n with 1? Right? Replace sine of n with 1, sine of n less than or equal to 1, and then this gives me 4 over n to the 4th. This is good. I have the inequalities in the same direction, and I know that 4 over n to the 4th converges by p-test. So therefore, I get the smaller one. Converges also by basic comparison test. Okay, so this is a fact I'm telling you. You need to know that ln of n is less than n. So if I just look at the graphs, right, like n would be like y equal x, right? This would be the graph of y equal x. This would be the graph of y equal ln of x. Yeah, this is smaller than this, right? Okay, just to give you an idea. So if I had something like this, other times I've said when you see ln's, integral test is good to use, but I can see I can't do the integral of that. A u substitution's not going to work, right? So that's why I'm going to use this as a starting point. So I'm going to write down ln of n is smaller than or equal to, just smaller than n, right? Now I'm going to build this by dividing both sides by n to the 4th. And what I see here, this gives me 1 over n cubed. So this sum of 1 over n cubed converges p-test. So therefore, I get that the smaller one converges also by basic comparison test. Whoops, I forgot my 2 to infinity and equal 2 to infinity. Okay, so it's true. If this is true, then this is true. Right? So if 2 is smaller than 5, then 1/2 is bigger than 1/5, right? That's what this is saying. Okay, so now I can use, so knowing this, you have this as a tool. So let's just go and use it. 1 over ln of n is greater than 1 over n. So here I have the summation of 1 over n. Again, just starting at 2 to make sure it's defined. That this diverges by p-test. So therefore, this diverges by basic comparison test because I have this smaller diverging. Okay, another fact I know you know, because you know the graph of arctangent, right? Don't you know there's the horizontal asymptote right there. So pi over 2. So if I'm starting at n equal 2, right? Arctan's like here, so I'd be talking about here to here. So it's all positive. So this is good because I need positive term series to do basic comparison test on. So I'm going to start by saying this is smaller than pi over 2. Whoops, I forgot my n there, didn't I? Okay, arctan of n is smaller than pi over 2. Okay, so then let's put the denominator in on both sides. I still cannot use p-test on this. But can I take the 3 off and keep the inequality? So is this true is what I'm asking. Can I keep the pi over 2, put the n cubed here, and take the 3 off? Is there more on the denominator here than here? Yes. So this works. Okay. So what do I know about this? Pi over 2 times 1 over n cubed, going from 2 to infinity. This converges by p-test. So therefore, the smaller converges also by basic comparison test. Okay, let's finish off this one more. So arctan of n, if n's are starting at 1, this is pi over 4, right? Because arctan of, tangent of pi over 4 is 1. And then it goes up here to this pi over 2, this asymptote, right? Okay, so I know that arctan of n for sure is going to be bigger than or equal to pi over 4. So if I'm looking at something like this, and I'm looking at an n to the 1 power, and I've got this arctan of n over n minus 1, I want to take away this 1, so I get smaller, this direction, right? Oops. Yeah, n. Okay, so take away this. So that gives me more on the denominator. So this is smaller. So I want to get rid of this so I can use my p-test. That's where this comes in. So this is bigger than pi over 4. So now I have pi over 4 times 1 over n. And going from 2 to infinity. And again, it's just to keep the denominator the defined. Then this diverges by p-test. So therefore, since it's the smaller, the larger must diverge also by basic comparison test. So how do you know which direction to go with arctangent? You kind of have to see where your problem's leading you. And I like to think of looking ahead like in chess. Oh, n cubed, I'm thinking p-test. That's going to converge. Here, n to the 1 power, I'm thinking p-test. That's going to diverge. So you get to look ahead and think.